A roadmap for the future direction of quantum simulation has been set out in a paper co-authored at the University of Strathclyde. Quantum computers are hugely powerful devices with a capacity for speed and calculation which is well beyond the reach of classical, or binary, computing. Instead of a binary system of zeros and ones, it operates through superpositions, which may be zeros, ones or both at the same time. The continuously evolving development of quantum computing has reached the point of having an advantage over classical computers for an artificial problem. It could have future applications in a wide range of areas. One promising class of problems involves the simulation of quantum systems, with potential applications such as developing materials for batteries, industrial catalysis and nitrogen fixing. The paper, published in Nature, explores near and medium-term possibilities for quantum simulation on analog and digital platforms to help evaluate the potential of this area. It has been co-written by researchers from Strathclyde, the Max Planck Institute of Quantum Optics, Ludwig Maximilians University in Munich, Munich Center for Quantum Science and Technology, the University of Innsbruck, the Institute for Quantum Optics and Quantum Information of the Austrian Academy. He said, "There has been a great deal of exciting progress in analog and digital quantum simulation in recent years, and quantum simulation is one of the most promising fields of quantum information processing. It is already quite mature, both in terms of algorithm development, and in the availability of significantly advanced analog quantum simulation experiments internationally." In computing history, classical analog and digital computing coexisted for more than half a century, with a gradual transition towards digital computing, and we expect the same thing to happen with the emergence of quantum simulation. As a next step along the development of this technology, it is now important to discuss practical quantum advantage, the point at which quantum devices will solve problems of practical interest that are not tractable for traditional supercomputers. Quantum simulation should be possible in the future on fault-tolerant digital quantum computers with more flexibility and precision, but it can also already be done today for specific models through special-purpose analog quantum simulators. This happens in an analogous way to the study of aerodynamics, which can be conducted either in a wind tunnel or through simulations on a digital computer. Where aerodynamics often use a smaller scale model to understand something big, analog quantum simulators often take a larger scale model to understand something even smaller. A particularly exciting way forward in the near term is the development of a range of programmable quantum simulators hybridizing digital and analog techniques. This holds great potential because it combines the best advantages of both sides by making use of the native analog operations to produce highly entangled states. The University of Strathclyde and all of the partners on this perspective article have large, active programs involving both theory. The partners have been collaborating as part of the Horizon 2020 EU Quantum Technologies flagship project PAS-QuanS. A quantum technology cluster is embedded in the Glasgow City Innovation District, an initiative driven by Strathclyde along with Glasgow City Council, Scottish Enterprise, Entrepreneurial Scotland and Glasgow Chamber of Commerce. The University of Strathclyde is the only academic institution that has been a partner in all 4 EPSRC-funded quantum technology hubs in both phases of funding. The hubs are in sensing and timing, quantum-enhanced imaging, quantum computing and simulation, and quantum communications technologies. Andrew J. Daly, Emmanuel Bloch, Christian Kokale, Stuart Flanagan, Natalie Pearson, Matthias Treuer, Peter Zoller. Practical quantum advantage in quantum simulation. Nature, 2022. 607, 7920, 667 doi, 10. 1038 per second 41586, 022, 04940, 6 University of Strathclyde. A Roadmap for the Future of Quantum Simulation. Science Daily. Retrieved July 29, 2022 from ift.tt/sdc08 at University of Strathclyde. A Roadmap for the Future of Quantum Simulation. Science Daily. ift.tt/sdc08 at. Access July 29, 2022. Thanks for watching. Please subscribe my channel for more videos.